Hey, in this video, let's discuss operator overloading. So we had discussed overloading in terms of function overloading by saying that it's sort of like making multiple names for the same function. For operator overloading, we're going to give new functionality to symbols using the same symbol but in different contexts. Sort of like when you use the plus symbol in order to add two integers, but you also use the plus integer or the plus operator to add two floats. Two different situations, but they're really similar. And operator overloading can be really powerful. It can make it easier to use your classes and use them more naturally, but you should be careful not to abuse it. If it's not obvious how a certain operator is going to work for your class, you should probably not be overloading it. So in Visual Studio, I want to try to create a class where we can demonstrate some operator overloading. So let's try a clamped integer class. This is going to be effectively an integer, but it's going to have a certain range restriction. So let's start off with that. Let's just make it public for now, a value, and then we're going to have to say what kind of range, a min value and a max value. And so let's see how much of this we can make. I'd like a constructor, a default constructor that just sets the value to 0, and let's give some reasonable min value of, I don't know, 0 and a max value of 10. I could make another constructor that lets me specify value, min value, and max value. Alright, using this crazy initialization syntax, min value, okay, and if you haven't seen me do this before, I'll just say I'll rename these so that they make more sense. C++ lets you repeat the name of the variables, as it knows how to tell them apart, even if they're named the same thing in this syntax. Okay, that's more clear. Okay, that's fine, and I don't even need a body here. Okay, so I want to make this clamped integer work like an integer, which means it needs to be able to perform arithmetic with integers. So if I was adding a clamped integer and a regular integer, I would like the result to be a clamped integer. So let me make a function that returns a clamped integer, and its name is going to be operator plus. So that's the identifier, the name of this function. And then in parentheses, I say what arguments it's going to accept. The plus operator, when you're doing addition, is a binary operator. That means it takes two operands. In C++, the way that we write this overloaded operator is that the first operand is implicit. It is this class, and so we don't even have to write it. So we just have to write the second operand. So int, let's say b. That's the right-hand side of the plus operator. And then we have to define what this is going to do. Clamped int, let's make a temporary one called I dot value is our value, I dot min value is our min value, I dot max value is our max value, and then let's do the addition. I dot value equals I dot value plus b. And then we'll return that, return I. So this thing has that value stored in it. Now this does not perform the clamping that we want. What we'd like to do is check to see if the value is too low, and if it is, just cut it off, stop it at min value. So if I.value is less than min value, then I value is the min value. And similarly, if it's too big, then we're going to set it to the max value. There we go. So that does some clamping. And I can redefine, or I can define all sorts of operators for this class, but I should only do the ones that make sense. I can go on and do subtraction and multiplication and division and all that stuff, and apply this idea of a clamped integer to all of that. And I'll do one more because I want to show the difference with another type of operator. This one, it looks like it's going to be the subtraction operator, but I'm actually going to define the unary operator minus right here. And by unary, I mean that it only acts on one operand. And you might be scratching your head, how does a minus operator only have one operand? This would be not subtraction, but negation. So taking the negative of a number. You only need one operand for that. So what this should do is just negate my my value, and I can do the same check as I did before. And a lot of this code could be copied, or I could factor it out into another function to make this a lot better. So now my value is just getting negated, and then I'm checking to see if it's still in the right range. Pretty easy. I'll make the actual subtraction operator now too. Operator minus, and I can just do it like that. That's pretty easy. Cool. All right, let's try it out. So let me make a clamped int. Let's call it I, and give it some value within some range. Whatever. There we go. Now we can see if we add some number to it, we should be able to add like 16 and print that out. And you should expect that this should have gotten clamped, so it should print out 12. And then if we do I equals negative I, we should be able to print that out, and it should be negative 12. And so it should give us a little idea of whether this is working correctly or not. So there are lots of other uses for operator overloading, some other common operators to overload. The assignment operator is actually one that's pretty important, so that you can determine how a special class might change when you assign a value into it. But for now, I want to go back to my vector class, and I want to overload an operator. I had an at function that sort of just accessed the internal array. There's an operator for that when you're just working with arrays normally. You usually use square brackets, right? So it would be nice if I could make my class work so that you could just use square brackets instead of calling a function. It would be a lot more natural. So let me make a function, operator square brackets, and I'm going to implement it all in this header file. So I'm writing it just like my at function, it takes an integer as an argument. Notice that the name of the function is operator with square brackets after it, and the one argument is the integer index. And if I look at my implementation for this function, it is just using an array access. So I'm going to be doing the same thing here, and it works just the same. There's a detail here though about my original app function that I'd like to fix. This is fine, and this is operator overloading and everything. But when you access using this notation with an array, you expect to be able to do anything with that variable, even assign into it to change it. And the way that I'm returning just t here means that I'm returning a value, and I'm not able to modify that value. What I would need is to return a reference in order to actually modify it. So I'm going to change my functions, both of these, so they return a reference. Great, that looks good. When I go, let me see, go back to my definition of this, make sure that it matches. And so now I'll be able to do more with these two functions. Now, we had done this, we had talked about this when we talked about exceptions, because there are cases when you cannot return a reference, a valid reference, and so you need to do something else. And often that means throwing an exception because there's nothing you could return that would make sense. All right, I will see you again in the next video.